Okay, so we're going to finish up some work on lesson 7-9. So this is 7-9, part 2. And if you look at page 252 in your book, we're talking about different figure number patterns. And so you can see the different arrays that are listed in the beginning, and it says draw the next 3 rectangular numbers. So before I even start thinking about the drawing, I'm looking for a pattern. And if you think about your pattern, I know that this one is 1 tall, and this is 2 rows tall, and this is 3 rows tall, and this is 4 rows tall. So I know this is 1 times something, and that's 2 rows tall, and 3 rows tall, and 4 rows tall. Then it's 2 wide, then 3 wide, then 4 wide, then 5 wide. And so I can see it's 1 times 2, 2 times 3, 3 times 4, 4 times 5, and so on. So if it keeps going in that same pattern, I could draw that next one, but if I stick with that pattern and we're going 1 high, 2 high, 3 high, 4 high, then this next one should be 5 high, and then after that would be 6 high, and then after that it would be 7 high, right? Because it's 1, then 2, 1, 2, 3, 1, 2, 3, 4. This one would be 1, 2, 3, 4, 5, okay? And then if we stick to the same pattern with a multiplication or array type situation, it's 2 wide, then 3 wide, then 4 wide, then 5 wide. So this one would be 6 wide, then 7 wide, then 8 wide, and so on. Okay? So now I could draw these out, and I could draw it as 5 tall and 6 wide. And then this one, I'll run out of space, so I'm not going to do all of that. But once I figure out the pattern, I can just solve how much each one is with the algorithm. I could see 1 times 2 is 2, 2 times 3 is 6, 3 times 4 is 12, 4 times 5 is 20, 5 times 6 is 30. If I were to do 6 times 7, that would be 42. And 7 times 8 would be 56, and so on, okay? That would be right here. So then, part 2, it says complete the list of the first 10 rectangular numbers. So if you look at letter A, it starts with the 2, then it says 6, 12, 20, 30, 42, and we would go here, that next one would be 56, but that next math problem would be one more here, so it would be 8 times 9, then 9 times 10, then 10 times 11, and so on, right? So for letter A, we know after 42, we would do 56, then we would do 8 times 9, 9 times 10, and then 10 times 11, okay? So when part B, when it says how did you get your answers, you could talk about that pattern of each of the factors went up by 1 each time you went over. So then number 3, it says continue the following pattern. It's actually doing the exact same thing. So when it says the first one is 2, then 2 plus 4 is 6, 2 plus 4 plus 6 is 12, 2 plus 4 plus 6 plus, what's the next one? And so hopefully you're seeing that there is, they're counting by multiples of 2. So 2 plus 4 plus 6 plus 8 is 20. Then 2 plus 4 plus 6 plus 8 plus 10 would be 30. And then you'd fill in that last one. So each time you know that they are skip counting or adding the next multiple of 2. So for letter B on number 3, so number 3B, you could say the pattern is adding the next multiple of 2. Okay. And then in letter C, it says, what pattern do you notice about the number of addends? Remember, an addend is a number that you're adding to something. Okay, so you can check your answers on that, and that's something that you really need to think about as you're doing the problems. If you turn to page 254, so you're going to skip 253 for now, and if you look at page 254, there's a few different division problems and multiplication problems. And so I'm going to actually do one of those division problems for you here just to kind of double check. We'll do it as a partial product, and then we'll do it also as traditional division. So letter A, number 3A, it says 5 divided into 485. Okay? So 5, I know 5 times 100 is 500, so I don't have enough for that. But I know 5 times 9 is 45, so 5 times 90 is 450. And I subtract that, and I get 35 left. And I know that 5 times 7 is 35, and my subtraction, I have nothing left. So my answer is 97. If I were to do that doing traditional division, 5 with 485. So as I do this, I know I'm going to do 5 times what is closest to 4. I can't do that. 5 times nothing. So I could put a 0, and I'll just skip that place. 5 times what is closest to 48? I know 5 times 9 is 45. And when I subtract it, 8 minus 5 is 3. And the 4's cancel out, so it's nothing. And then I'm going to drop my next digit down. 5 times what is closest to 35? 5 times 7 is 35. And that's it. And so I have my 97 here and my 97 here. So keep practicing all of these. If you have questions, ask your teacher during office hours, and good luck.